Hi, in this video we're going to explore using a queue for a real-world problem. Problem's going to be a printer simulation. And what this is going to be is think about a computer lab where you have so many computers set up on it and one printer. So as students come in to use the lab, they're going to be needing to print, and those print jobs are going to go into a print queue. So what we want to do is do a simulation to see how long does it take for these print jobs to get done when they have a lot of students coming into the lab. Will it be feasible to get another printer or a better printer that does better quality? So that's what we're going to do here. We're going to write a program that will simulate this. We're going to use a queue to simulate the print queue. And this is in the book. So you can read through this to figure out how to do this. But I'm going to start off with that one of the things we have to do is figure out some ways of being able to do this. So I'm going to pull this over and go through this a little bit with you here so you can see this. So consider the following situation in the computer science laboratory. On an average day, about 10 students are working in the lab at any given hour. These students typically print up to twice during that time, and the length of these tasks range from 1 to 20 pages. The printer in the lab is older, capable of processing 10 pages per minute of draft quality. The printer could be switched to give better quality, but then it would produce only 5 pages per minute. The slower printing speed could make students wait too long. What page rate should be used? Okay. So here's a little picture of this computer science lab where you have all these printers, and then all these tasks go into the queue to go to the printer. Okay. We could decide to build a simulation that models the laboratory. We will need to construct representations for students' printing tasks and the printer. As students submit printing tasks, we will add them to a waiting list, a queue of print tasks attached to the printer. When the printer completes a task, it will look at the queue to see if there are any remaining tasks to process. Of interest for students, or for us, is the average amount of time students will wait for their pages to be printed. And this is equal to the average amount of time a task waits in the queue. To model this situation, we need to use some probabilities. For example, students may print a paper from 1 to 20 pages in length. If each length from 1 to 20 is equally likely, the actual length for a print task can be simulated by using a random number between 1 and 20 inclusive. This means that there is equal chance of any length from 1 to 20 appearing. If there are 10 students in the lab and each prints twice, then there are 20 print tasks per hour on average. What is the chance that at any given second a print task is going to be created? The way to answer this is to consider the ratio of tasks to time. 20 tasks per hour means that on average there will be one task every 180 seconds. So this is calculated like this: 20 tasks per hour times 1 hour per 60 minutes equals 1 minute for 60 seconds equals one task 180 seconds. For every second, we can simulate the chance that a printer task occurs by generating a random number between 1 and 180 inclusive. If the number is 180, we say a task has been created. Note that it is possible that many tasks could be created in a row, or we may wait quite a while for a task to appear. This is the nature of simulation. You want to simulate the real situation as closely as possible, given that you know general parameters. So here's the main simulation steps. I'm going to create a queue to print tasks. Each task will be given a timestamp upon its arrival. the queue is empty to start. For each second, which is current second, does a new print task get created? If so, add it to the queue with the current second as the timestamp. If the printer is not busy and if a task is waiting, remove the next task from the print queue and assign it to the printer. Subtract the timestamp from the current second to compute the waiting time for the task. Append the waiting time for that task to a list for later processing. Based on the number of pages in the print task, figure out how much time will be required. The printer now does 1 second of printing if necessary. It also subtracts 1 second from the time required for that task. If the task has been completed, in other words, the time required has reached 0, the printer is no longer busy. After the simulation is complete, compute the average waiting time from the list of waiting times generated. So now to design the simulation, we will create the classes for the 3 real-world objects described above: printer, task, and print queue. The printer class will need to track whether it has a current task. If it does, then it is busy, and the amount of time needed can be computed from that number of pages in the task. The constructor will also allow the pages per minute setting to be initialized. The tick method decrements the internal timer and sets the printer to idle if the task is completed. So we're going to create this. Get everything set up here. Okay, so I'm going to create a new file. We can get started here. So we're going to need to import random. So we can randomly select how many pages and how often a print job comes up. And then from my QU, import QUEUE. Okay. Start a class printer. And then our INIT. And we have self and our pages per minute. So our self dot page rate is going to be equal to pages per minute. Self dot current task is going to be equal to none. Oops. And our self dot remaining is going to be equal to 0. And we're going to have our method called tick. And here we're going to check to see if self dot current task does not equal none. Self dot time remaining minus equals 1. Subtract 1 second off if self dot time remaining is less than or equal to 0. Self dot current task is going to be equal to none. Okay, so we finish the task. We're going to have a method called busy. And we're just going to check to see if self dot current task does not equal none, return true, else return false. And then we're going to have one called start next. And in here we're passing in a new task, self.current task. It's going to be equal to new task. self dot time remaining is going to be equal to new task dot get pages, which we haven't created this yet, times, go down to the next line, 60 divided by self dot page rate. Okay, so some of these this one here is going to be a new one, the new task we haven't created yet. Dot get pages, and then we divide that, or 60 by self dot page rate for how many pages per minute, and multiply that times this to see how long it's going to take. Okay. Okay, so let's go back over to this. Okay, so then the task class will represent a single printing task. When the task is created, a random number generator will provide a length from 1 to 20 pages. We have chosen to use the rand range function from the random module. So that's showing how to create that there. Each task will also need to keep a timestamp to be used for computing waiting time. This timestamp will represent the time that the task was created and placed in the printer queue. The wait time method can then be used to retrieve the amount of time spent in the queue before printing begins. So let's go ahead and do the task class. Oh, don't need that up there. Okay, so we do our INIT. Self, and we pass in time. Oops, that's current task. Self.current task is going to be equal to new task, self.time remaining equals new task dot get pages. Oh, sorry, I'm on the wrong line there. Well, let's take this out of here and go down to the right line. It's self dot timestamp equals time, self dot pages equals random dot rand range 1, 41. And that should be 21. Okay. I've been doing some modifications on this because we're doing 20 pages, so 1 through 20. Okay, then we got to get stamp. We're just going to return self dot timestamp. Then get pages. We will return self dot pages. Then we have our wait time. And we got pass in current time. And then here it's going to be return current time minus self dot timestamp. Okay, and that's everything that we need for the task. Okay, so let's go back. So the main simulation implements the algorithm described above. The print queue object is an instance of our existing queue ADT. A Boolean helper function, new print task, decides whether a new printing task has been created. We have again chosen to use the randRange function from the random module to return a random integer between 1 and 180. The print tasks arrive once every 180 seconds. By arbitrarily choosing 180 from the range of random integers, we can simulate the random event. The simulation function allows us to set the total time and the pages per minute for the printer. Okay, so this is the simulation here. So the book broke this all up into different sections, and I'm trying to put it all together here for you. So we're going to do a simulation. We're going to pass in num seconds. Oops, let me there we go. Pass in num seconds and pages per minute. So we're going to have a lab printer spell here. That's going to be equal to printer passing in pages per minute. We have a print queue equal to queue. Waiting times is going to be equal to an empty list. Now we don't have our printer, or I'm sorry, we don't have our printer class created yet. Oh, I'm sorry, that was the first one we did. So we got our printer class created. And so that's what we're doing here is calling our printer class and passing in pages per minute. So lab printer is going to be an object of that. Put some blank spaces in here so I can get that up higher. Okay, so we're going to do a for loop. So for current second, in range num seconds, if new print task equals task current second, print queue dot enqueue task. If not lab printer dot busy, and we'll go down to the next line here, not print queue dot is empty, next task equals print queue dot dequeue. Waiting times dot append, next task dot wait time current seconds. Lab printer dot start next task. Okay, and then we have our lab printer dot tick, because that seconds up, and then we're going to calculate out our average weight. It's going to be equal to a sum of waiting times divided by the length of waiting times. And we're going to print average weight percent 6 point. Whoa. There we go. I must have hit something. Get this out of my way here. Weight 6.2 F seconds percent 3D tasks remaining dot quote, and we'll go down to the next line and put in percent average weight print queue dot size. Okay, now this is written differently in that we don't have the F on here and set up like the newer Printway on here, but this is an older program. I just didn't have the time to fix all that, so you can work with that and change this to a print F format on there if you want to. Okay, so let's go back. And see what the next thing is that we need to do to get this finished up. We're getting close. Okay, so we're going to need to put this new function in here, new print task, so that we would calculate out if there's a new print task, so that if the number is equal to 180, then we return true, else we return false. Okay, and that's right there, if new print task. Okay, so we're going to put that function in there, and then we'll do a main function to test it out. This is not in a class anyplace, this is just in the program itself. So num is going to be equal to random dot rand range 1 comma let me get the right one here because I've been playing around with this. 1 comma 181, and then if num equals 180, we're going to return true. Oops. Else we're going to return false. Okay, so that's the entire program. And so all we need to do is put in our main. And in our main, we're going to do for I in range. We're going to start off with running this 10 times. Simulation, we're going to pass in 3600 seconds and 5 as how many pages we can print. Well, let's do the 10 because that's the non-quality part of that. Okay, so let's see if we can get this to run and save this. I'm going to call this print. Print simulator.py. I think that's already in here. Yeah, so what I'm going to do is back up here and go into this location because I don't have it in there. Okay, save it. And let's see what happens when we run. Whoops. Does that every once in a while to me. And there's my first error. Pages per minute, so I got to go up here to printer. The page rate is misspelled there, so take that out of there. And I got pages per, I don't have a capital P on there. So we'll fix that. Whoops. And let's try it again. I'll have some errors in here. There's a lot of code. There's another one. New print task is not defined. So see, I got left the N out of there, so I got to find where that is. Right there, I left the N out. Okay, let's try it again. Try to be so careful with making mistakes, and you still end up with a lot of mistakes. Okay, so wait times. So wait times dot append. And it's right here. It should be waiting. Waiting times. Okay. Another one, current seconds. In next test, dot wait time, current seconds. I got current second, so not seconds. There we go. Self dot time remaining equals new task dot get pages, and it says get pages. Did you mean? So I misspelled that. Right there. And there we got it to run. Now, this particular one, this is the wait times, and it was able to go through all the tests. There was no tests remaining. So it's not too bad on that, okay? But what if we want to go with high quality, okay? So we're going to change this then to 5 because that was the high quality on there, and then we'll run this one. And see, now the wait times are a lot longer. You consider a minute is 60 seconds. So if you would divide these by 60, that would give you how many minutes there are. So the longest one here looks like 212. So that's not quite 4 minutes. You can see here how many tasks were left over after the 3600. Okay, but now what if the lab gets busy and we get one every 160 instead of 180. Okay, look at this one here. We have 12 tasks remaining. Okay. Times have gone up 315, 281. Okay. Let's see, what else can we do to make a change in here? What if the average pages goes up to, like I had on here before, 40 pages? Students are printing out a lot more. Now look at how many tests are being left over and how long these are. Some of them up over 900 seconds, almost 1,000 seconds. So you divide 1,000 by 60, so that'd be 6 into 100 would be over 10 minutes to wait. So that's why you do this, and then what you could determine is, well, if that's the case, if students are having to do larger documents, the 41, they have to have the better quality because that's what needs to be turned in for the assignment. And instead of doing one every 180 seconds, they're doing one every 160 seconds. Okay. So now, do we need to add another printer to the queue? So um, this works for a lot of queue situations. You just have to modify the names on them and everything. But just to give you an idea of how you can use a queue in a real world situation. Okay. Thanks a lot. Bye.